Hello, math magicians. Here we are again, learning something new in Algebra 1. And so let's jot down some notes. This is going to be notes, lesson 9.3. And we're going to learn a new way to solve quadratic equations. Alright, so these are your notes. And we're still solving quadratic equations, but we're learning a new method. It's called completing the square. Alright, so let's just do a little review. Let's remember what solve means. So solving means that we're looking for, you're trying to find the x-intercepts. Alright? You're looking for the x-intercepts. That's what solve means in this case when we're dealing with quadratics. And if you remember, x-intercepts are also called zeros. And they're also called roots. Okay, so if you see those words, zeros or roots, it just means x-intercepts. And then don't forget that the quadratic equations are of the form y equals ax squared plus bx plus c. Okay, when we're done with this unit 9, we are going to end up learning, we will have learned 5 methods for solving quadratic equations. Okay? Alright, so we've already learned 3 of them actually. Okay? So the first one is by graphing. So the first one is just draw a graph, and then you can see the x-intercepts, and you can find the x-intercepts. So quickly, to draw a graph, you need the axis of symmetry. And remember that's x equals the opposite of b over 2a. You need the vertex. And remember, you just plug in the opposite of b over 2a. So once you find the opposite of b over 2a, you plug that in, and you'll get a y value. And that's your vertex. You'll need to find the y-intercepts. And that is the easiest. You just actually substitute 0 in. You plug 0 in for x, and you'll get another y value. And you have to keep in mind, this y value here is not the same as this one. When you plug this value in, you get a y value. That's different than when you plug 0 in. Okay, so these are not the same. I guess they could be, but not usually. Alright, and then the last thing we do is we find the x-intercepts, which is what we're actually looking for when we solve. And to find the x-intercepts, you set it equal to 0 and factor. Set equal to 0 and factor. Okay? Okay, one other important thing is when we're solving quadratics, there will either be one solution, 2 solutions, one solution, 2 solutions, or no solutions, or none. Let's just say none. Whoops. Wow. Try that again. One solution, 2 solutions, or none. Okay, so sometimes, now we've noticed, hopefully you've noticed, there are some times when you can't factor. Sometimes you can't factor. So we will need another method. Alright, let's keep going. Actually, factoring is one of the other methods. Alright, so set it equal to 0 and factor. And then you'll have to use the zero product property. And remember, factoring, it could be a GCF, It could be the difference of perfect squares. It could be a trinomial, either an easy trinomial or a hard trinomial, or it could involve grouping. Okay, but again, sometimes they can't be factored. Okay, the latest method we just learned was the square root method. And what you do, you have to isolate the squared term first, and then you actually take the square root. This method only works when it's this form, y equals ax squared plus c. Alright, it only has a squared. It doesn't have just a linear term. It doesn't just have a regular x. It'll have an x squared. Okay? And remember, you have to isolate. You have to get the x squared alone and then take the square root. Alright, that brings us to our final, or our new method. So our new method is going to be completing the square. So this is what we're going to learn today, completing the square. And this works when it has a leading coefficient of 1, when the trinomial has a leading coefficient of 1. So ax squared plus bx plus c, but the a is a 1. Alright? So that's really important. And then as you can see, there's one more method, and it's the quadratic formula. I do think some of you have heard of that before, but we're not going to learn that till next week. Now, when you're completing the square, what you're actually doing here is you're going to make a trinomial square. All right, so let's try like 3 examples on the back.